All right, everyone, welcome back to a Grit Daily Startup Show. I'm your host, Jordan French. Super excited to talk about a topic that I think affects everyone, and I think Norman Stewart will agree. Author Norman Stewart is here on the show. Well, Norm, welcome to the
Thank you
show.
very much, Jordan. Great to be here.
Yes, and for the inquiring minds who want to know already, we see some pictures that look a little not so familiar for North Americans behind you. Where are you coming in and calling in from?
I'm in Dublin, in Ireland today.
A good few, I'm sure our audience have been there. I have myself.
Great.
Um, yeah, appreciate that. And an author, you have a new book that came out just a few months ago.
That's correct. Yeah,
Yep.
I have a copy here.
Freed from the Iron Grip of Frost. There's a lot to unpack there, Norman. A lot to unpack there. But just to lay some foundation, for the uninitiated, with your own background, you clearly have extensive curiosity and some expertise within sort of the environmental space. Share more, Norm.
Yeah, I trained as a meteorologist when I was young. It was actually my first full-time job, my first real job. I was at the UK Met Office. But prior to that, when I was an undergraduate at Trinity College in Dublin, doing physics, it was a time when a lot of the early work in computer modeling was being done on climate change, what we now call climate change. And there were regular articles coming out about the developments in computer modeling and so on, some of which I referred to in the book. And that's where my original interest started. And then when I became a meteorologist, I developed my more deeper understanding of what was actually going on. I moved out of that area, went into industry. But in the 90s, when it started to become a big political topic and with enormous economic and social implications, I really developed an interest in it, tried to keep up with it. And actually, the way the book came about was that I looked for books on the subject. There's lots of stuff on the effects and forecasts and so on. I was looking for something on the underlying physics, and I couldn't find anything. So eventually, during COVID, I had a bit of spare time, and I just decided to write my own.
Yeah, and appreciate that foundation, Norman. You brought up something that we find to be like really important in the relationship between uh, science, essentially, and then industry, politics, and the word believe comes up a lot when it relates to climate change, right? People will often ask the question, uh, do you believe in climate change? Or do you believe in, global warming, right? It's sort of like a colloquial term to capture all that. And I just want to repeat this back to you because I think it's really important. One thing that certainly was missing was that sort of scientific underpinning, right? That and recording what's there, uh, helping people understand that it's not really just a belief, especially in your view, not just a belief, but there are actual causal reasons and there's a science behind it, right, Norm?
Oh yeah, yeah. If anything, it bugs me a little bit that there's too much in the public domain. There's too much, let's call it belief. There's too
Right.
much unquestioning acceptance. My angle is we really need to get back to the science. Science is not about belief; it's about evidence. I want to see and present the evidence and give people a chance to first of all to understand where this comes from, where the information comes from, where the ideas come from, where the theories come from, where the forecasts come from, how it's all done. To see the sausages being made, to use a term we use over here. Yeah, it's for me, it's all about the science.
Right, and it's refreshing, and you also deposited practically a fact, not just an opinion. There is too much. There's a lot. Certainly, I'll put that out there, Norm. There is a lot in the public domain about usually people are not scientists on sort of both sides of the argument when perhaps there shouldn't even be sides. If anything, it sounds like more scientists should take up the mantle themselves and stick to the facts. Let's dive in that though with the book. The title alone is curious, and I'll repeat it for everyone out there, and we can show it again, Norm. And that is freed from the iron grip of frost. Let's unpack that, for everyone, and maybe even work it backwards might be even easier way to unpack that. Norm.
Well, the 19th century Irish scientist John Tyndall, he wrote um, that England, he was working in England at that time, England without the greenhouse effect would be held fast in the iron grip of frost. What he was referring to was the fact that if there were no atmosphere to provide the greenhouse effect, then all the heat from the surface of the Earth would radiate out into space, and the Earth would be roughly 33 degrees Celsius colder than it is right now. So in other words, the mid-latitude countries like England would be just covered in frost, held fast in frost. So what my title is saying is that the greenhouse effect frees us from the frost, uh, which would otherwise pertain.
And in some ways, it's an inversion, meaning, just thinking about what that means, right? You refer to 33 degrees, even whether that's Fahrenheit or Celsius, which you can, or Kelvin if you prefer, but that's going to be some Celsius. However you want to deposit that, that's a significant departure from where we are today. Uh,
Massive.
the world would be a lot cooler. That would have huge ramifications on, well, pretty much everything and all the business that we're doing, every day, going about our business, and huge, I imagine, also political ramifications. And so let's dig a bit of a layer deeper in some ways, and just to get inside of his head. Uh, what he was referring to was it's actually perhaps a good thing, good for industry, that the greenhouse gases have been released to some degree. You have a slightly warmer climate and more habitable for humans. Is that one tack or approach, at least initially, and viewpoint that he shared, Norm? Or is it completely the other direction? That instead, any change in temperature is bad, where we should be, in fact, is about 33 degrees cooler than where we are today, or at least where he was when he made his measurements. Norm?
Yeah, in the book, I'm really reporting the facts. Now, the structure of the book is I've written it historically. Um, on the one hand, my main ambition is to get across the physics, but in terms of presentation, I've structured it by historical episodes. So I've chosen a set of particular people, interesting characters, who advanced our understanding of the field in their time. So it covers 200 years of human endeavor. Now, obviously, during a period like that, things change. So you get many different viewpoints. There were people in the 19th century, a man called Arrhenius, who thought it could be a good thing that it might. One of the obsessions in the 19th century was, when is the next ice age coming? What will it be like? And some people said, well, maybe if the Earth were warmer, that could help keep off the next ice age. So there are many different perspectives on this. Some of them are explicit in the literature, and I refer to these. But I'm looking at it. I'm trying to be objective. I'm trying to report what people actually said at the time, and there are many different perspectives on it.
Yeah, certainly. It's almost worth asking, and I think I'll ask this question, Norm. Consider your viewpoint is written from, present day, right? It's 2020s, 2 decades after. And certainly, I think we could all agree, especially given your example, we were all closely listening from Arrhenius, who, argued perhaps if there's another ice age coming, maybe a warmer planet, it's helpful to mitigate that. Maybe there's some serious downsides, right? We want to give him the benefit of the doubt. Let's think about, perhaps 50 or maybe 100 years. I'll let you choose one. What will climatologists, meteorologists, people grounded in the science here, right? Physicists be thinking, if you can give us a glimpse of that, looking backwards, right, at that time? Perhaps there's even more we can learn by sort of projecting into the future and then looking backwards. Norm, thoughts on this idea?
Very difficult. It it could go anyway, to be honest. For me, all that we can do at this point in time is to inform ourselves of what's gone before and the best state of knowledge right now. Really, for me, the our current understanding is really not good enough to allow us to be confident, to make commitments about the way it'll go in the future. Maybe there's just a little bit overconfidence, in fact, in our current state of knowledge. Maybe one of the things I'm saying is, from a historical perspective, maybe we need to be a bit more modest, a bit more acceptance that as ever in science, our knowledge is never 100%. We need to be willing to accept improvement, to accept that sometimes we make errors, that the next set of measurements, the next set of models, the next discovery could revolutionize the way we see it. And we need to be modest enough, and we need to be willing to accept the possibility that we stand to be corrected.
I think equally refreshing in Norm, and then modesty is, certainly a characteristic or trait. I think we could all certainly use more of, me included, 100%. Uh, Now, back to the book specifically and the physics, it'd be really helpful at this juncture to also define, if you could share, because I think we'll have a lot of people curious about reading the book. Perhaps what do we know then, given this foundation you just laid? And then perhaps also, what do we really not know, Norm?
Well, it's first, I start out by describing the basic greenhouse effect, which became clear in the early 19th century. It's clear that without the greenhouse effect, without the effect of molecules in the atmosphere on infrared radiation from the surface of the Earth, the world would look very different. I mentioned the 33-degree warming that we benefit from due to the molecules in the atmosphere doing their thing. So that's clear. Then the question is, what happens when you change the concentration, the density of certain molecules in the atmosphere? I think it's pretty clear there that it does have an incremental effect on the warming of the Earth. Additional concentration of carbon dioxide, methane, certain other gases. It does have an impact on the temperature of the surface of the Earth. Um, uh, that's for me, that's clear enough. The quantitative effect, though, the extent to which it impacts the temperature of the Earth, I, that's not quantitatively. It's not so clear. I think we have a lot of work to do to reach a state where we'd be confident of to any degree of precision of the actual impact. And then the question of what secondary effects do we have in terms of weather due to that. When you look at the IPCC reports, you find that actually the discoveries, when you do proper statistics, discoveries on the impact on things like hurricanes, typhoons, flooding, droughts, etc. It's not as clear cut. The We still have a lot of work to do on that.
I see, I see. Yeah, so and to repeat that last part back to you, there's definitely, back to the sort of immodesty, especially in news media, just a sort of blatant belief, a causal, right, relationship between climate change, global warming, let's say, temperature increase on the surface of the Earth, and then adverse sort of meteorological events. Just repeating that back to you, Norm. Did I generally get that right? Or and
Yes.
that is and that sort of feeling of certainty is perhaps not as firm as we all maybe are thinking or believe.
Yeah, when you look at the technical reports from the IPCC, you don't see that degree of certainty. You don't see that degree of catastrophism. You don't see the alarm uh, that we see in the news media, that we see from politicians. That's true. Um, in a sense, I'm trying to act as a scientist. I'm probably being naive. I'm being very old-fashioned. this, this is maybe not the way we do things in the modern world, uh, but I'm trying to restore a culture of focusing on the science. And I would just point to the IPCC technical reports as being an example of how this can be done.
Yeah, yeah. So it does lead to this next question, Norm, which is, we've all seen and also seen reported in popular and mainstream media, a huge number of scientists signing off on, in the thousands, supporting climate change accords, signing off on, certain, documentation or confirmation of climate change, temperature change. Um, what do you make of that as well? Is that also something that perhaps is overweighted or maybe misunderstood what actually is going on there, Norm?
Well, that's it's probably a misreported state of affairs. Now, it's really not something I go into in the book. My book is really focusing on the science and the history. But with regard to that, it's it's not what people think. You don't do surveys in science. You don't do opinion polls in science. That's not how it works. The the reports about 97% of scientists agreeing with something. They're not derived from opinion surveys. They're derived from inspecting published papers. Now, I don't want to go into that, but the methodology is very, very different from what people are led to believe in the media.
And then naturally, the next sort of area to dive into again, going back to the book, certainly, is there some incremental data that you would want to see? Not from an opinion standpoint, right? Either way, but in terms of helping us form some possible improvement in conclusivity. Norm?
Well, one area that's terribly important is water vapor in the atmosphere, both in gaseous form and in liquid form, i.e., clouds. Clouds are a hugely important part of this mechanism, and one of the least well understood, one of the worst understood. Until we get a good handle on clouds and the impact of clouds on radiation, I think we have to regard our understanding as being pretty primitive. There is evidence over the last 2 to 3 years that for some reason, the cloudiness of the Earth has reduced. The amount of low cloud in the atmosphere has reduced, and that would be expected to cause warming. Um, if you have less cloud, you have a lower what's called albedo. Less of the solar radiation is being reflected away. More of it is getting into the surface, which is bound to cause warming. That those kind of effects of clouds really need to be nailed down much better than we have them at the moment. So
Yes.
water in all its forms, hugely important topic that we really need to. Now, when you look at the models, um, for example, Manabe was one of the guys that was influencing me back in the 70s. He was publishing, this is Professor Siakura Manabe at Princeton University. In the early 70s, he was publishing the results of his computer modeling on the effects of change in gases in the atmosphere. Manabe knew that the effect of carbon dioxide alone was relatively modest, but he, along with many others, said once you get a small amount of warming from carbon dioxide, that warming will lead to a higher concentration of water vapor in the atmosphere. And the water vapor is a much more powerful greenhouse gas, and it will cause a knock-on effect of additional warming. So typically people use a factor of 3 between the effect of carbon dioxide alone and the effect of carbon dioxide plus water vapor. So water vapor is a huge factor. It has an enormous impact, but it's very poorly understood.
And Norm, turning to the last word of the book title, frost. There's been much made of the sort of impact on a relationship rather between the polar ice caps, where at least generally we understand that's where a lot of greenhouse gases are captured. Do check us on that assumption as well. Um, and that reference to the frost in your book. Could you share more on that, Norm?
Yeah, John Tyndall was a man, a physicist, but great interest in mountaineering, glaciers, ice. Um, in when he realized that the important contribution of the atmosphere and of the greenhouse effect on the climate of, in his case, England, when he realized that the moderate climate in England was maintained by molecules in the atmosphere, he was looking for a way to poetically get the idea across to the man in the street how important this was to the country. And he used this poetic description that if you were to take away the atmosphere, or if you, in fact, if you were to take away the water vapor, is more precisely what he said, from the atmosphere, then all the heat in the surface of the earth would just radiate out into space. He says this explicitly, and the country would be left in the iron grip of frost. Now, looking at the glaciers, that goes back even further to the first character in the book. In fact, the first scientist to work seriously in this area, a man called Fourier, Baron Fourier, a Frenchman at the time of the French Revolution. He's a great character. He was a revolutionary in the French Revolution. He sided with revolutionaries like Robespierre. In fact, he upset Robespierre and he was condemned to execution on the guillotine. And he was extremely lucky. He was saved from the guillotine just by the fact that Robespierre was sent there first. Robespierre was executed. So as a result of that, Fourier was released. Now, he was interested in glaciers because he'd heard reports from people in areas like Switzerland about strange rock patterns, isolated boulders, rocks. And the only way people could explain this was that they were pushed there by ice. So this was mainly in the 18th century. People like Hutton in Scotland. So the idea developed during the 18th century that there had been much more extensive ice fields previously than there was at that time. Some theorists, some people said, "Oh, these come and go very quickly." Others said, "No, this is something that happens over a long, long timescale, over millions of years." So the idea of ice coming and going, which has climate implications. The idea that the climate was fluctuating in the historical past, the remote historical past. This was something that was really current in Fourier's time, around about 1800. So Fourier was coming into this intellectual environment where people were saying, well, the climate has been fluctuating. Look at these rocks. So Fourier tried to understand from a point of view of the physics what might be causing this. So this was what led him into this trying to understand how the Earth is in terms of climate, what drives the Earth's climate. And one important consideration that he touched upon was the greenhouse effect. He realized that the atmosphere is keeping the Earth at a moderate temperature, otherwise it'd be much colder. He developed the idea that what's happening is you've got sunlight coming in to warm the Earth. The atmosphere is largely transparent to sunlight. That's what warms the surface of the Earth. But then that energy is turned into heat in the surface of the Earth, and the heat tries to radiate away in infrared frequencies. So the Earth doesn't emit much in the way of visible frequencies, but it does try to emit in infrared. Now we have a difference. What comes in is visible, but what's going out is infrared. But somehow, and Fourier realized this, somehow the atmosphere doesn't transmit infrared radiation, the way it does visible radiation. There's something about the atmosphere that impedes radiation of infrared out to space. And it's this difference in the way the atmosphere responds to visible light versus infrared light. This was one of Fourier's great discoveries. Now, he didn't understand it in terms of physics. Physics at that time was very, very primitive. But he had this qualitative notion that this must be where the idea lies. It was really only 100 years later when we had quantum mechanics and we were able to analyze the behavior of molecules. We could calculate molecular spectra and understand quantum molecular spectra. It was only then that we realized what was happening between molecules and infrared radiation, why molecules react to infrared radiation and how they do so, and the fact that they operate in discrete frequencies, and the fact that there are only certain parts of the spectrum where molecules are active and absorb infrared radiation. But the basic intellectual parameters go back to this man Fourier, who was a very interesting character. Another aspect of his life was that Napoleon recognized his genius as an organizer. So Napoleon took him on the trip to Egypt when Napoleon tried to take over Egypt. Um, he got Fourier to set up various educational institutes for science in Egypt. He was involved in various explorations and scientific work. And then when Napoleon realized that the game was up and he took himself back to France, he left Fourier and his army behind in Egypt, stranded, surrounded by the British. And it was only through the good graces of the British that he was able to get home. They took him back to France.
He owes them one, Norm.
Indeed. But
And
I think he paid the world back with his scientific work.
it does seem that way for the engineers out there who or those who've attended any schooling in that domain.
Yeah.
Uh, that's the same Fourier that we're referring to from most,
For
I believe, most commonly electrical engineering concepts to which he's contributed.
Certainly, yes. Fourier transform, Fourier series. Now, it's interesting. In one of his papers, which I read for the book, he says he says very pointedly that his the whole idea for the Fourier series. Um, Fourier series is where you represent a function as a sum of sine and cosine functions, periodic functions. He says that the idea came to him in considering the heating of the Earth. So the Earth is rotating. So the sun goes around once a day. So it's a periodic 24-hour heating pattern. And it was this idea of the periodic regular heating that led him to the idea of representing periodic functions as sums of sines and cosines. So the Fourier series goes back to meteorology.
Yeah, I certainly appreciate you uh, highlighting that relationship, for us well, and also that background. Certainly an interesting character, and people can read about it in the book. And then just sort of one more area I definitely wanted to touch on. It does relate to the frost polarized capture. We just brought that up, but it also relates to that sort of periodicity, right? That sort of uh, oscillation, and it's on everyone's mind in this audience, and it's very simple. It's simply as a question: why doesn't, from this point on, the temperature of the surface of the Earth continue to increase, perhaps not linearly, right, but in one direction, given all of the foundation that you offered us? What is that major sort of break or check on the system that is grounded in science, that's a natural phenomenon, Norm, that does cause these ice ages, I think, as sort of historians and archaeologists call it, that causes these, over huge periods of time, significant swings, both downwards and not just upwards in temperature. Norm?
Yeah, there are many different factors driving climate. You mentioned ice ages. Um, the um, the widely held theory nowadays of ice ages is that it's due to astronomical effects. The Milankovitch theory. Milankovitch came up. He did enormous work on analyzing ice ages. Um, his theory is that it's changes in the orbit and the tilt of the Earth that drive ice ages. Now, I have a chart in the book showing temperature for the last 2.5 million years, which is roughly the Quaternary Ice Age, and we can see temperature variations on a time scale more recently of 100,000 years, which corresponds to the cycles that Milankovitch was predicting. So there's a major driver of climate. And one very interesting question is when that is still there. When will the next ice age come? Um, the current interglacial that we've been living in for the last 14,000 years is an unusually long one. Previous interglacials have been quite a bit shorter, so you could say we're living on borrowed time for the next glaciation to arrive. That's one driver. When you look at a much, much shorter time scale, when you look at a time scale of 10, 15, 20 years, if you look at the average temperature of the Earth, you do see major fluctuations up and down. These are driven by El Nino. The El Nino Southern Oscillation, ENSO, has a significantly observable impact on global temperature. We've just come out of an El Nino and a subsequent La Nina. We're now in a fairly neutral phase. That's another driver. There are the most recent El Nino is a bit of an anomaly, a bit of a mystery. Most people regard the warming that took place up to a year to 2 years ago as being mostly, people assumed it was due to El Nino. We've had many of those in recent in the last 50 years that we've measured. But this one was just a bit bigger and difficult to explain. So people are finding it hard to account for the warming that we got in 2022, 2023. And a lot of people are putting it down, at least partly, to this change in the cloudiness of the planet. The reduction in low cloud was a big part of that 2023 warming. The temperature has dropped a bit since then in very, very end of 2024 and into 2025. It recovered from that warming, and it's dropped a few tenths, 0.3 of a degree since then. But that's proving difficult to explain. So there are many different factors.
Yes, certainly, Norman, and really appreciate you nerding out in a sort of a very sort of comfortable, wise way. Though at the same time, I think we could go on for sort of hours listening and have conversation with you. I'm sure so many questions will continue to come in. Uh, even well after the article and the audio on this are published. But I'm getting the nice green flag from our editor, so I will pin it here. Uh, I do want to make sure that people who want to pick up a copy of your book and who do want to read it know where to get it. Norm, I know it's available on Amazon, and we'll drop that link in the article. If we could just show the book one more time so they see the image. Yeah, the
There we
Freed
go.
from the
Yeah.
Iron Grip, yep, of Norman Frost. And then for people who want to get in touch with you specifically, Norm, what's the best way for people to reach you?
Probably email Jordan, Norman James Stewart at gmail.com.
Well, there you have it, everyone.
Delighted
If you
to.
want to read, yeah, open to all the fan mail, questions, and curiosities. It's certainly an ongoing conversation, that's for sure. And again, refreshing. The third time we'll use that word, Norman. Look at climate change, global warming from a scientifically grounded perspective. And Norm, I'll give you the last word for everyone before we sign off. Norm, takeaways.
Thanks very much, Jordan. Great to talk to you. Yeah, for me, this is the biggest science story from a social point of view we've ever had. In the social, the political context, science doesn't get any bigger than this. And I really want the population to understand what's happening in the science. I think it's terribly important that we, as a population, understand what's actually happening.
Yeah, appreciate that. No, and certainly important. So we never hear the end of it. That's for sure, Norm, and certainly quite a few conventional wisdoms that I think very healthily could be checked for sure. That's all the time that we have for Startup Show. Hope you enjoyed this episode, and until next time, thank you.
It was great to be here, Jordan. Thank you very much. Bye.